Hi, my name is Austin Pecci, and today I will be presenting the carbon fiber commodity chain. Carbon fiber is a lightweight, super strong material that is loved by engineers and designers everywhere for its unique physical properties. It has proven strength 5 times stronger than that of steel, 2 times as stiff at 2/3 of the weight, and has the ability to be molded into most any shape used in manufacturing today. Carbon fiber is basically very thin strands of carbon, even thinner than human hair. These strands are twisted together like yarn and woven into a cloth form. The carbon fiber is then laid over a mold and coated with stiff resin to create the designer's desired shape. The process is very similar to that of paper mache. The raw materials used to make carbon fiber is called the precursor. Carbon fiber is made from organic polymers, which consist of long strings of molecules held together by carbon atoms. 90% of carbon fibers are made from polyacrylonitrile, while the remaining 10% are made from rayon or petroleum pitch. Now, unfortunately, the exact composition of each precursor varies from one company to another and is generally considered a trade secret. So making your own carbon fiber at home might take a little more effort than mixing powder with water and throwing it in your easy bake oven. The process for making carbon fiber is part chemical and part mechanical. The five main operations to form carbon fiber from polyacrylonitrile, or PAN, include spinning, stabilizing, carbonizing, treating the surface, and sizing. In the spinning step, PAN is mixed with other ingredients and spun into fibers, which are washed and stretched. Next, the stabilizing step stabilizes the bonding through chemical alteration. In the carbonizing step, the stabilized fibers are heated to very high temperatures, forming tightly bonded carbon crystals. The surface of the fibers is then oxidized to improve the bonding properties in the treating the surface step. And in the final step of sizing, the fibers are coated and wound onto bobbins, which are loaded onto spinning machines that twist the fibers into different size yarns. These steps are universally utilized to create high-grade carbon fiber. Listed are some of the top suppliers leading the carbon fiber manufacturing industry today. For the sake of simplicity, we will focus our attention on the efforts of Cytec Industries. Cytec has 15 manufacturing sites in the US, 2 in Latin America, 7 in Europe, and 3 in the Asia Pacific region. Cytec has carbon fiber customers in the aerospace, automotive, defense, and energy industries. The expanse of Cytec's Industries sales is global, with delivery methods spanning from aquatic to aerial. Because there is such a prevalent demand for carbon fiber and because it is used in so many industries, Cytec offers an express delivery option. Cytec's two main express delivery options include road shipping and air shipping, allowing for a speedy transport overseas. The road delivery option includes roughly a €250 handling fee, while the air delivery option just about doubles that. Two of Cytec's main customers in the aerospace industry are Boeing and Airbus. To highlight the various distances that carbon fiber companies must travel to deliver their products, I've provided a map. The yellow upside-down teardrop symbols represent the locations of the carbon fiber supplier Cytec Industries. The purple hammers represent a few of the many customer locations of Boeing, and the blue airplanes represent the customer locations of Airbus. As you can see, the delivery routes some carbon fiber suppliers must take are quite expansive in distance and in number. Cytec Industries strategically placed their aerospace carbon fiber manufacturing sites all over the United States to improve delivery time to customers. And to put things into perspective, this map only covers 2 of the carbon fiber customers in the aerospace industry alone, and it's just some of their known locations. Remember, carbon fiber is delivered all over the world because of its applicable uses in all industries. So these are just a few of Cytec's vast carbon fiber manufacturing locations. So how much is carbon fiber going for these days? Is it something cheap that I could use for my kid's art project? Carbon fiber is actually fairly expensive. According to a sampling of people at the JEC America's Composite Trade Show, carbon fiber in the automotive industry costs about $10 to $12 a pound. which is more than half of the $35 price tag it had a decade ago. This dramatic price decrease is attributed to the spike in carbon fiber usage. More engineers and designers are identifying the beneficial qualities of carbon fiber and incorporating it into their systems. However, although the cost of carbon fiber has seen a significant decrease, it is still nowhere close to the less than a buck price for steel. Looking at the plot on your left, the positive increasing slope line exhibits the growing usage of carbon fiber in more and more industries. The negative sloped line exhibits the decreasing price of carbon fiber over the years. As you can infer, there is a direct correlation to the increased usage of carbon fiber and the decreasing price of the material. The plot on your right is a carbon fiber manufacturing company's representation of the decreasing price and increased usage relationship for carbon fibers. It further exemplifies the carbon fiber trend. So how do these companies like Boeing and Airbus use carbon fiber? Boeing's newest aircraft, the 787 Dreamliner, is made up of nearly 50% carbon fiber composites. This feat has never been done before. It has revolutionized the aerospace industry and taken aircraft performance and efficiency levels to new heights. Airbus's A350 XWB wide-bodied aircraft has a fuselage made of mostly carbon fiber reinforced plastic. In the automotive industry, high-performance automobiles like Lamborghini are taking advantage of the strong, lightweight material. Lamborghini just put their Sesto Elemento onto the production floor. This car has the majority of its body made of carbon fiber, significantly reducing its weight and drastically improving its performance. Formula One also uses carbon fiber to enhance their handling. The advantages of carbon fibers are not limited to the transportation industry. Companies are making great strides in the energy industry to utilize carbon fiber in things like wind turbine blades, allowing them the same strengths in their current material, but at a lighter weight, which allows the system to harness more energy. When a composite structure reaches the end of its service life, disposal becomes an issue. Historically, composite components from retired aircraft and junked automobiles have been disposed of in landfills or incinerated. While landfills remain the least expensive option, in 2004, most European Union member states passed laws forbidding landfill disposal of composites. Further, incineration of plastics is suspect because of the potential release of toxic byproducts, which would contribute to air pollution, global warming, and factors regarding food growth. Also, during the production process, gases are produced that are expensive to dispose of, which also contributes to the $10 to $12 per pound price tag of carbon fiber. For example, during the carbonization procedure, about 50% of the weight of carbon fiber is lost as gases, such as water, ammonia, carbon monoxide, carbon dioxide, nitrogen, hydrogen, and possibly methane. An inert gas is used to dilute the toxic waste gas in a gas extraction system, as well as to prevent ingress of atmospheric air. The treatment and disposal cost for the hydrogen cyanide byproduct increases the production cost of the pan-based carbon fibers. This goes to highlight the need for innovation within the carbon fiber disposal industry. So what about recycling? Recycling typically involves four basic steps: collection, identification separation, reclamation, and remarketing. Recycling is practical only if the value of the reclaimed raw material exceeds the cost of the recycling process. Here, carbon fibers present some unique difficulties for recyclers because of the complex nature of the product. A composite can be made from a number of materials that are much more difficult to separate, and in the case of thermoset composites, cannot be reclaimed through a melt process. Since the idea of recycling composites was first conceived, the greatest challenge has been to develop a profitable recycling process. While technology advancements have made carbon fiber recycling more practical, reclaimed fibers emerge from the recycling process in a chopped or milled form, which can't be used because of its poor form. So technically you can recycle it, but you can't really use it. On the open market, recycled carbon fiber is unlikely to approach even the low figure of its nearest competitor. Still, A small group of pioneering carbon fiber recyclers at Adherent Technologies believes it is not only possible but probable that reclaimed carbon fiber can be sold at a significantly lower than virgin but still profitable price, and expect market opportunities to expand as their recycling technologies are further refined and perfected. The recycling of carbon fiber and other like composites becomes more and more important as usage increases. Scrapping these used materials could have a significant impact on the future of our world. We have the power to revolutionize the technological world of tomorrow, but we must continue to find ways to simultaneously sustain the earth. Thank you. That was my presentation for the carbon fiber commodity chain. Please feel free to email me if you have any questions. Thank you.